Okay, so picture this. You are walking through your garden and you see a snail. What do? Probably nothing because it's just a snail, right? It's moving at like 0.03 miles per hour. You could literally outrun it while crawling backward. The most dangerous thing about it is maybe stepping on it barefoot, which is gross but not exactly life-threatening. Now imagine you're underwater, surrounded by a completely different set of rules. In that world, even a snail can be lethal, and some of them are among the deadliest creatures in the ocean. So how did a creature this slow end up with the ability to kill in seconds? The answer isn't the snail itself, it's the environment it evolved in. Welcome to Ocean Depths. Let's figure this out. Land snails, the weakest link. First, let's look at land snails because their environment never forced them to become anything more than simple survivors. These guys are so weak that you can kill them with literal salt. Not like a bucket of salt, just a few grains. Sprinkle some salt on a snail and watch it basically melt. It's like their kryptonite. Why me? Because land snails are essentially water balloons with shells. Their bodies are full of moisture, and when salt touches them, it sucks all that water out through their skin. It's called osmosis, which is a fancy science word for salt steals your water. The snail shrivels up and dies. Game over. Their diet is also super boring. Leaves, dead plants, maybe some mushrooms if they're feeling fancy. They're basically eating things that can't fight back or run away. A leaf isn't going to escape. It's just sitting there waiting to be eaten. So on land, snails never needed to evolve weapons, speed, or complex defenses. Their food doesn't run and their environment doesn't demand it. Their biggest threats are birds, beetles, and the occasional human. For survival, hiding in a shell was more than enough. Water changes everything. But then you go underwater and everything flips. Ocean snails are living in a completely different world with completely different rules. First off, that whole salt kills snails thing doesn't apply here. Ocean snails literally live in salt water 24/7. How? They adapted. Over millions of years, their bodies learned to balance the salt inside their bodies with the salt outside. It's like they upgraded their software to handle the salt update. But the bigger change is what they're eating. In the ocean, snails can't just munch on plants anymore. I mean, they could, but there's way more protein swimming around. Fish, shrimp, other snails. The problem? All of that food can swim away really fast. Imagine you're a snail trying to hunt a fish. You move at snail speed, which is extremely slow. The fish moves at fish speed, which is extremely fast. You can't chase it. You can't outswim it. You can't even get close to it before it notices you and bolts. So how do you eat? You have to get creative, really creative. Enter the cone snail, the sniper. Meet the cone snail, a creature shaped by its watery world into a perfect predator. These snails look pretty normal at first glance. They have a cone-shaped shell with cool patterns on it. Looks like something you'd pick up as a beach souvenir. That would be a massive mistake. Cone snails are armed with one of the most powerful venoms on Earth. We're not talking, oh, it hurts venom. We're talking, you could die in minutes venom. One drop of their poison can kill 20 adult humans. 20. That's an entire classroom. The amount needed to kill you is so tiny that it's basically invisible. We're talking 0.029 milligrams, which is lighter than a grain of sand. If you got stung by one of these, you'd need way less venom than what fits on the tip of a needle to die. How does it work? Here's how cone snails hunt, and honestly, it's terrifying. They have this specialized tooth that they turned into a harpoon. Yes, a harpoon. It's hollow, sharp, and loaded with venom. The snail keeps it hidden in a tube-like part of its body. When a fish swims near, the snail doesn't chase it. It just waits, and then at the perfect moment, it launches the harpoon like a tiny spear gun. The harpoon shoots out, stabs the fish, and instantly pumps it full of venom. The venom doesn't just hurt the fish, it completely shuts down its nervous system in less than a second. Every muscle in the fish's body locks up at once. The fish goes from swimming to completely frozen mid-water. It doesn't struggle, it doesn't swim away, it just stops, like someone hit the pause button on its life. Then the snail slowly crawls over and eats it. Problem solved. Why so much overkill? Now you might be asking, why does the venom need to be strong enough to kill 20 humans when they're only hunting small fish? Great question. The answer is because they're still slow as hell. If the venom took even 5 seconds to work, the fish would swim away and the snail would lose its meal. The snail also loses its harpoon when it shoots, so it can't just keep trying. It's one shot, one chance. So the venom needs to be instant death. Not hurt a little then die later, but dead before you hit the ground level of fast. That's why it's so insanely strong. It's not overkill. It's necessary for a predator that moves like a glacier. What happens if you get stung? If a human gets stung by a cone snail, things get bad really fast. Some cone snails even inject a numbing agent first, so you might not feel the sting at all. You just notice your hand going numb, then your arm, then your chest. The venom attacks your nervous system. Your muscles start failing. You can't move properly. You can't breathe properly. Eventually, your heart might stop. And here's the worst part. There's no cure. No anti-venom exists because the venom is made of hundreds of different toxins mixed together. Doctors can't make an antidote for something that changes from snail to snail. Your only option if you get stung is to get to a hospital immediately and get hooked up to a breathing machine. Then you just wait and hope your body can filter out the poison before you die. That's it. That's the only treatment. Luckily, deaths are super rare because most people never see cone snails. They live in specific tropical areas, and they're not that common. But when people do get stung, it's usually because they picked up a pretty shell without realizing what it was. Freshwater snails, deadly because of water. Next, we look at a snail whose danger comes not from venom, but from how water spreads parasites. Freshwater snails look super boring. It seems small, plain, and slow, harmless at first glance. Yet water turns them into a vehicle for disease, making them deceptively deadly. And technically, the snail itself is harmless. It won't bite you or sting you, but it'll still kill you. How? By being a walking parasite factory. The parasite problem. These freshwater snails host tiny parasitic worms inside their bodies. The worms use the snail like a breeding ground, making thousands of copies of themselves. Then they leave the snail and float around in the water as microscopic larvae. These larvae are invisible to the naked eye. You can't see them in the water, but they can see you. Well, not really see you, but they can sense you. And here's the scary part. They can burrow through your skin. You don't need to have a cut or wound. They literally drill through healthy skin like it's not even there. You could be swimming, washing clothes, or just walking through shallow water, and boom, you're infected. You won't feel it happen. No sting, no bite, no pain. The larvae are too small. You'll probably have no idea you were infected until weeks later when you start feeling sick. What happens after infection? Once inside your body, the larvae travel through your blood to your organs. They settle in around your liver, intestines, or bladder. Then they grow into adult worms and start laying eggs. Thousands of eggs, every single day. The eggs are sharp and they tear through your tissues trying to get back out into the water. But most of them get stuck inside your organs. Your body sees these foreign objects and freaks out. It tries to fight them off with inflammation, but there are too many eggs. Your organs start getting damaged. Scar tissue builds up. Things stop working properly. This disease is called Schistosomiasis, but most people call it snail fever. It's the second most destructive parasitic disease in the world, right after malaria. It affects over 240 million people. It kills nearly 200,000 people every year. And most of those deaths happen in poor areas where people don't have access to clean water or medicine. Why freshwater snails? So why do these parasites specifically choose snails as hosts? Why not fish or turtles or something else? Because snails are perfect for them. Snails are slow, so they stay in one area. They're everywhere in fresh water, and they live in exactly the shallow water where humans go to bathe, wash clothes, and get drinking water. The parasite doesn't need to chase anyone. It just waits in the water where it knows humans will eventually show up. It's a trap that works perfectly. Why water makes snails deadly? So what is it about water that makes snails so dangerous? Why don't we have deadly snails on land? It's all about delivery. On land, if you have venom or parasites, they stay with you. You can't spread them unless you directly touch something. But in water, everything spreads. Venom can be delivered through harpoons. Parasites can float around freely. Water carries everything. For the cone snail, water means their prey is always moving, so they needed a weapon that works instantly. For freshwater snails, water means their parasites can travel and infect people without the snail doing anything. Land snails never needed to evolve these abilities because their food doesn't run away and their environment doesn't help spread anything. They're just slow creatures eating plants and hiding from birds. But water snails? They're living in a completely different game with different rules. And they adapted to become some of the most effective killers in nature. The human element. The sad part is that most deaths from these snails are preventable. With cone snails, people die because they don't know what they're picking up. Those shells look really cool, so tourists grab them without realizing they're holding a loaded weapon. With freshwater snails, people die because they don't have clean water access. Millions of people have to use rivers and lakes for everything. Drinking, bathing, washing. They know the water might be contaminated, but they don't have a choice. It's either risk infection or go without water entirely. Scientists have tried killing the snails with chemicals, but it doesn't really work long-term. The snails come back, the parasites come back, the cycle continues. So here's the bottom line. On land, snails are basically harmless. They're slow, weak, and die from salt. They eat leaves and hide in their shells. The most dangerous thing they do is maybe ruin your garden. But in water, snails are completely different. Some became precision killers with instant death venom. Others became mobile factories for parasites that infect millions of people. It's all because water changes the rules. In water, everything moves, everything escapes, everything spreads. So snails had to adapt or die out. The cone snail adapted by becoming a sniper. The freshwater snail adapted by hosting parasites. Both strategies work incredibly well. And that's why you should never underestimate a snail just because it's slow. On land, they're harmless. In water, they're killers. Always check what you're picking up at the beach. And if you're in an area with freshwater snails, be careful about which water you touch. Because sometimes the slowest creatures are the deadliest ones. Not because they're fast or strong, but because they found clever ways to work around their weaknesses. Nature is wild like that. If this whole snail transformation story was as crazy to you as it was to us, hit that like button, drop a comment, and subscribe to Ocean Depths. What other ocean creature should we dive into next? Comment below because we're just getting started with the weird stuff the ocean has to offer.